Problem 2, continue evaluating the progress of the 8th Mile Highway construction project. So continue with problem 1. Status update after 4 months, 3 miles completed and 5 million has been spent. After 6 months, 5 miles completed and 10 million has been spent. How has this contractor performed for the last 6 months? Develop a SPI CPI chart to monitor project performance. So SPI CPI chart. Before that, I just want to go back to the slide of today's lessons to monitor the project's performance. The slide number 3, you see the chart with the SPIs at the horizontal axis. SPI stands for Schedule Performance Index. CPI represent as the vertical axis, stand for Cost Performance Index. And want to see the dynamics of the project status in terms of cost, schedule, over time. Let's give one symbolic here. When you start, everything is start at 1, CPI as 1, SPI as 1, and that is start at the origin. In this case, 1, not 0, 0. So you have that. After 1 week, if it go down to the bottom left, as you can see there. So in that case, both SPI and CPI is less than 1. It means that the project is unfavorable. Both schedule and cost are unfavorable. What does that mean? The schedule is behind schedule and cost behind over budget. And then you have week number 2. It go a little bit better in terms of the schedule. So go to week 2. SPI greater than 1 is ahead of schedule, but CPI still less than 1, over budget. Then move to week 3. Both are favor. Then week 4 even better. Week 5 good zone. Week 6 in this case it's under budget but behind schedule. And then week 7 ahead of schedule, under budget, very good. And then week 8 is behind schedule and over budget. So we want to see the dynamics of that, and when you see that status, you can be able to make corrective actions for the project to make sure the project on track. So that we want to demonstrate that in this problem. So before we need to find out the SPI and CPI for each update. In the problem 1, we have the after 2 months, and I do it very detailed. If you don't know, go back to that to find out. But here, I just want to go quick about to find out SPI, CPI for each of the update, 4 months and 6 months. So we already know in the problem 1, the plan is 1 mile per month, and the BAC, budget at completion, is 12 months, and the total duration is 8 months. So after 4 months, 2 miles complete. So that's why you have actual percent complete is 37.5%. 3 divided by 8 miles. The plan percent complete, 1 mile 1 month. I explained that in problem 1, and now it's 4 months. So you have a plan complete is 50%. So you can be able to find out the PV4, 6 million, EV4 unvalue at month 4, 4.5 million, and the actual cost is 5 million. It's given in this problem. And then that we can determine the SPI for schedule performance index equal to EV over PV, and the cost performance index EV over AC, and both less than 1, so behind schedule and over budget. 0.75 for SPI and 0.9 for CPI. After 6 months, we can be able do similarly for the percent complete, 62.5% actual, and the plan percent complete is 75%. And again, you go back to problem 1 to see how I did that in detail. And we can find out the PV6, EV6, and AX6 equal to 9 million, 7.5 million, and 10 million respectively. And from that, we can find out the SPI at 6 months, CPI after 6 months, 0.83 for SPI and 0.75 for CPI, and both are less than 1. It means behind schedule and over budget. And now we want to draw the chart that is the question asked us to do, SPI and CPI. So we go ahead to do that in this one. You can have the SPI and CPI in here. So let that be SPI for the horizontal, and you have CPI, and our SPI for the month 2, problem 1, if you recall that number is that number is equal to SPI number 2. If you remember that, let me check here. So it equal to SPI 2 equal 1 and CPI 2 equal to 1.5. So that means the 1.5 maximum. So we can get this one here with the division for this is 1.2, 1.4, and 1.6 because the maximum is 1.5. So we have 1.2, 1.4, and 1.6. And then similarly for the CPI, 1.2. So that the intersection is 1, 1, not 0, 0. Keep that in mind. 1.6. And here 0.8, 0.6, 0.4. Similarly, 0.8, 0.6, and 0.4. And keep in mind just a note from problem 1. From problem 1, we have SPI 2 equal to 1 and CPI 2 equal to 1.5. Go back to your problem 1 so that we have that number. So what does that mean? At the beginning, it will be at this point. And then after 2 months, SPI equal 1, so it means on the vertical axis, and CPI 1.5, so it go to this E month 2. So the arrows go from the origin to here, to month 2. And for month 4, we have SPI 0.75 and CPI 0.9. So 0.9, 0.75 and 0.9. Then we have this is the this is 0.8, this is 0.7. So 0.75 that here and 0.9 there. So you can have that. So we can have that is the arrow going down to that, and that in month 4. And we can be able to have that at 0.75. Go to this number, and this is 0.9 for the CPI 4. And then the month number 6, SPI 6.83 and CPI 0.77, 0.77, which is and 0.83. So we have that is 0.9, 0.83 it means here, and then 0.75 for the SPI, CPI. So we have 0.7, 0.75, 0.75. You see 0.83. So let me erase this first. Just put here, that's in month 4 there, and then we have month 6, it going down to yes. So with that, we can be able to find out the track status of project from very good, ahead of schedule, on budget on month 2, go back behind schedule, over budget month 4, and behind schedule, over budget month 6. But it seems the schedule is better, it improving, but the cost go more, even more over budget when we move from month 4 to month 6. So that is problem 2. In the next problem 6, you apply the unvalue method to determine and forecast the construction time and cost.